Good afternoon. You have to scream because I don't see you because of the light. Good afternoon, good morning, whatever time it's. Okay, you're alive, thank you. So one thing before I start, this presentation is like 1 hour, 50 minutes. So I need to compress it into 45 minutes. So if you start losing your breath, it's okay. I will go too fast. And make sure that you're on the right talk because this is black metal Java, not bare metal. I changed title like 5 minutes ago, so. Okay, quick. My name is Jarek. I live here in Krakow, and I will have in September 5-year anniversary at Neo4j. We built a graph database in Java. Crazy. And I'm staff engineer there working in the benchmarking performance, all the boring stuff, I mean, all the crazy stuff connected to the performance of the database. And yeah, you probably know me. If not, you will know me after the talk. Okay. One thing on the slide that is important, I spent over 20 years with JVM, and I still love it, but it's tough love. Disclaimer, because we are living in strange times where people tend to cancel other people because somebody said something and somebody feel offended. So to make sure that you don't cancel me, actually I don't care because I'm not on social media, so you can cancel me. And I'm not making money from public speaking, so you can cancel me as well. I don't care, it's my hobby, okay? No matter how hard you try to cancel me, it didn't work. But to make sure that you are warned, I tend to sometimes talk about sex, drugs, alcohol, religion, and politics in the same sentence. It happens. Not often, but it happens. So if you will feel offended by anything I say, that's okay. Because it means you have some values you care about in your life, okay? So I'm just old, so I can complain. Question. Do you want like soft erotic version of this talk or hardcore late night? Hardcore late night, okay. I knew it. So I will skip the theoretical discussions and we'll straight go to things. The agenda for today is a little bit of history, but you want hardcore, so will be not enough history. And then we'll move directly to code examples, not compiling code, and all this funny thing happen when you do live presentation. Okay. Oh, I see slides here. So quick. This is my own taxonomy of programming languages. There are like zillions of taxonomies, but my own taxonomy is I split languages into compiled, like C, C++, but directly to native code. Then you have still compiled, but languages that require some small, tiny runtime, like Go, for example, or Pony, where the runtime is linked into your binary and it does some extra stuff. And then you have a long list, like majority of languages now, these days, are managed runtimes. So Lisp, Smalltalk, Java, C#, JavaScript, and all this long list of popular languages, all these languages are managed, run in managed runtime. What managed runtime means? So basically, somebody takes care of the complex stuff. Somebody else, not you. So it's, of course, memory management, so you have garbage collectors. You don't have to worry about memory. Then you have thread management. You don't care. You just do new thread, and everything is beautiful until some moment. Code management, so runtime linking of your code and dynamically loading code when your application is running. Calling native code, because this is interpreted in most cases. So you want to have some way to call native code. And then some of the runtimes provide operating system abstractions. OK, quick, next. If you think about the most popular languages now in the top 10 index, what's the name of this index? Tiobe? Yeah. So it's mostly managed runtimes languages. Why? Because it's better to give up control for safety. And I'm not talking about security, I'm talking about safety. Safety in terms of that your program wouldn't crash at some random point of execution. This is what constantly happens when you write C, C++. Things randomly crash in most unexpected places. So you give up, you use manage runtime to do all the hard stuff, so you can focus on doing the important stuff. And you give up control over memory allocation, data layout in memory, threads, and so on. And you get safety, but you lose control. Basically, what you get from managed runtimes is three kinds of safety. It's memory safety, so you wouldn't get like dangling pointers. If you get memory, if you get object, you know that things are there. Nobody deallocated it. Everything is safe. Then you have operation safety. So if you execute some operation on an object, like for example, iterating over array, you wouldn't go over the index of this array, or you will get an exception instead of crash. Yeah? So this is operation safety and execution safety. It means you wouldn't execute some random code. Of course, it still happens, but the code you execute is exactly what you wanted to execute. So this is what the managed runtimes give you. Okay. The thing is that when you give up control, you lose opportunities to optimize the code, because JVM knows better. The managed runtime always knows better. It thinks it knows better. Sometimes doesn't. So it means I don't want to say that managed runtimes are slower, but it's harder to optimize some things because the managed runtimes does stuff. Compiles code for you, manages memory, and so on. So the thing is that Java as a managed runtime language is a really stupid choice for system-level language. What I mean by system-level language? Writing databases, operating systems, queuing system, message brokers, and so on, It's a stupid idea because you want really high performance for the database or your message broker, but you are not able to optimize, or it's super hard because managed runtimes is always tries to be smarter. Okay? But if you look at the ecosystem today, all things we think about, should be high performance, they are written in Java. Apache Kafka, it's JVM. It's Scala, but it's JVM. Neo4j, parts are Scala, parts in Java, it's JVM. Elastic, Hazelcast, Cassandra, the majority of the Apache big data ecosystems, which you expect to be fast, are written in Java. Are these people stupid? Yeah, I know from a lot of them. They are not. They are just crazy. Because when you write database, and it's in my case, you want to trade safety for speed because you don't want your database randomly crash during storing your important precious data. So that's why I think one of the reasons there are many databases now written in Java and message brokers written in Java, because we want safety for free, not security safety. But you still want speed, okay? At the end, you select some database because it's fast, okay? You select Apache Kafka because it's fast. So what happened over years, Java had some tiny class called unsafe, where in the header of the class is written internal use only, don't use it. You know what happened? When you say don't use it, it means like invitation, like just do it. So we were able in Java to do some low-level stuff using the unsafe, undocumented internal API only. So we were able to allocate memory outside of heap. We were able to check the object layout, had some low-level concurrency controls, and do nasty things with serialization. The problem is it's unsafe. It's in the name of the class. So what happens, it's my observation, is there is a lot of effort in the JVM, in OpenJDK, to bring Java closer to metal. That's why it's bare metal Java talk. So there are lots of different projects, sub-projects, that try to say, okay, we know hardware advances, the operating systems are getting better, we don't want to be left behind, so we will provide more APIs for the low-level stuff so you can run faster. So during this talk, I will focus on the two things. the foreign memory and foreign linker, but there is also vectorization. I think this talk is today. Somebody will be talk, about SIMD. And then we have frozen arrays, primitive objects, which will be part of Valhalla and of low-level concurrency, but were introduced with the var handles. Okay, now the talk. malloc. You could do malloc in Java right now already. It's like hidden a little bit. So one thing you can do is direct by buffer. Yeah, direct by buffer at the end, it allocates memory outside of heap. And Java manages when you free the object, the direct by buffer, it will deallocate and free allocated memory. It is there. It's used, for example, by Netty. Of course, Netty has a bunch of wrappers around it and a lot of black magic, but it's there. It's inefficient under pressure. Because you delegate the allocation to GC, you will free off-heap memory only when GC happens. So if you have a lot of allocations, it can get nasty. Then you have this famous unsafe that breaks memory safety guarantees, and it's not official API. It can be removed. It can be changed. And of course, if you're crazy, you could use JNI to do memory allocation. Okay. So now we have a JEP, Java Enhancement Proposal, which is a long history since Java 14. Lots of changes in incubating phase. Then there are actually two APIs that were merged into one. At the moment, the state we are in, the things I'm going to show you are in the preview. So it's no longer incubating feature, it's preview feature. You still need to enable preview when you run programs, and still API can be subject to change, but it's getting there. I don't know when it's going to end. I don't know. I'm not sure even if it will be final in Java 21. It's hard to say. They are still working on it. So all the examples I will show you are based on Java 20. Every JEP has this nice section about goals and non-goals, and every change in Java has said, like, okay, what do we want to achieve with this change? So first of all, with the set of changes I'm going to show you, we want to create something that is better than JNI in terms of working with it, maintainability, and all this kind of stuff. You will no longer have to work with C to call C program, okay? You will just use pure Java, no compiling some nasty wrappers and doing crazy things. The next thing is it should be comparable with performance with SunMISC, Unsafe, and JNI. So as long as it will be slower, probably they will be keep trying doing preview releases of this feature. It should be general. So basically, at the end, the API should work with any native language. So assumption is the first version will work with C only libraries, and on 64-bit platforms. But the API that we are going to provide should work in future with C++, Fortran, and other platforms. Okay. And of course, we want safety. So we give you access to low-level things, but we'll still make it safe. They will not re-implement JNI. JNI will stay. Maybe at some point of time it will be sunset, but it is here to stay. And they were not going to re-implement existing APIs on the top of this. It will be separate API and so on. Okay. Boring, 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 boring. Okay. So what happens? What you get with foreign memory and foreign functions is three key classes: is memory segment, segment scope, and memory layout. Okay. Code. Do you see code? It's okay? Size? So basically what happens is, if you want to allocate something outside of heap, you need to go to memory segment. And memory segment is basically, in this API, a segment of memory. It can be anywhere. And that's interesting. They don't only focus on outside of heap memory. What they do is, you can allocate things outside of memory. You can allocate, outside of heap. You can allocate things on heap and still use the same API. And you can allocate things, for example, in memory map files. So you will have the same API to work with different types of memory. Okay? So this is memory segment. And this is the simplest possible case where you say, okay, give me 1 kilobyte of memory segment outside of heap, so this is allocate native. And then you can have two operations. One operation is you set value on this offset, and this is the value. So you say, OK, please write Java long on this offset, so on 0, the first byte in the segment, and write this value, OK, black metal Java. And then what you can do, you can go and say, give me this value back. One thing that is important is this. So every memory segment has something called bounds. And there are like 3 types of bounds. Limits, first is the size bound. It's called spatial bound. You cannot write outside of it. You will get the regular exception. So JVM won't crash. It will get index out of bounds. Okay? So it will behave like an array. So we have memory safety. The next thing is temporal bounds. So the question is how long this memory is available. Okay? You can think about it like a session. You create, allocate memory, and attach it to a session. As long as session lives, it's called scope. It was in the previous version of API called session. As long as the session is alive, all the memory segments are located within the session are alive. When you close the scope, everything will be freed, and the memory will go back to the operating system. So you have different types of scopes. One is global, so it means I allocate and I never deallocate. So welcome memory leak. Okay, welcome back. The memory will be free when you exit from JVM. Another type of scope is auto. What it says is when we lose reference to this memory segment, so when the garbage collection cleans the memory segment, then I will free the memory afterwards. Okay, so you delegate this work to garbage collector. And of course, the example works. I won't spend too much time on running these examples. Trust me, just trust me. So you can read and write from this memory. Simple as this. And there is third bound called thread confinement. So basically, what we can say is you can create memory region and say only this thread can read and write. So any access outside of the thread that created the memory segment will end up with the exception. Okay. So if we go to, here. So very special thing called arena, and arena is, the previous name was better. So you say everything that will be open within the scope of this arena, as you can see here, you create confined arena, and then you have scope, and you allocate memory in the scope. It means when I close arena is auto-closable, so you can use the try with resources. Thing. So when I close this memory segment will be free. Okay? So you can now directly manipulate when you allocate and when you deallocate. You don't have to wait for a garbage collector to clean things. But in our world, like databases, it's really important to free resources as soon as we can. Okay? And now, interesting thing. You have two things in here. One is set at index, and the other one is get. Do you feel like get by index and get by offset? Do you feel what's the difference? OK, this program will crash. Please crash. Yes. It will say that this is misaligned access to memory at this address. And the problem is here. Okay, so offset means bytes. So 0 is 0 byte, 1 is second byte, 2 is third byte in the segment. Index looks at the size of the things you are trying to write. So if you say index 1, it means 8 bytes of the segment, because it knows long is at 8 bytes. So index 1 is 8 bytes in the segment. So when you try to write long on the offset of 1, this is unaligned access memory, so it will throw exception. This is fine, because I say 1, and I take, OK, this is Java long, so I calculate this is 8 bytes from the segment. And here I want to write 8 bytes on something that is unaligned, so that's why you get exception. Is it clear? Aligned, padding, Anyone? Yeah, that's clear. Cool. And here we have the confined. So it means if I take this memory segment, this one, and I will pass it to another thread, and will try to do anything like get or set on it, it will end up with error. Also, this is an example. If you try to do anything outside of the scope, it will say, OK, I'm sorry, you cannot write to this memory because it was already closed. OK? Go. And here's an example of confined access. When you say, OK, I create things here, and then I start, and I try to write in different thread, and it will crash. Yeah, it will crash and will say, sorry, but you try to access this memory segment from the thread that doesn't create this one. How to fix it? You can say, OK, I know what I'm doing, and I'm a responsible person, and I will create, sorry, writing in front of people is not my superpower. You will have, it will work then. Come on. That's OK, because you create shared scope, and everything is fine. OK? Stupid example. Sometimes I have stupid examples. Oh, I don't have 5? Math is hard. So we know now what is memory segment and what is scope. The next thing that this API provides is something really fancy called memory layout. So memory layout is a way to describe what's actually in the memory. Because when you allocate, you get like sequence of bytes, and it can be anything. Then you can say, OK, I know what's in it, and I want to describe what actually it is. Okay? So memory layout, it can be a sequence of things. It can be struct. We should still learn C. And it can be a union. See anyone? Just one. Hello world. Have you written everything? Yeah. That's why the humanity is going to collapse. So you can describe that this is what you have in the segment, and then have. That's not the best API to work with it, but then you don't have to remember that something is on the 7th byte, or something is on the 8th, or something starts on here. You don't have to remember because you have a structure that describes it. So here's an example. I say, I want to have a memory layout that is collection, array, 16 Java longs. Okay? So it will now calculate, OK, 16 Java longs, so it's 16 times 8, so this is how much memory you need. So now we have the sequence layout. Now you can say, OK, allocate, but then you don't say the size of this thing. You don't have to, sit down with a pencil, calculate how much memory you need, because this thing will know, and say, OK, please allocate a space for this layout in this scope. OK? This is the end of soft erotic part. Some time ago, I don't know the number there are too many Java versions. We complained that they are doing things slow. Now it's too many Java versions. Some time ago, they released something called var handles. So var handles is a way to work with variables in Java. And by variable, we mean field on class, field on object, an element in array. And var handle is like a kind of a pointer to, it's not exactly a pointer, but kind of a pointer to this concrete variable. And what I say is, I want to have access, okay, create var handle to the second element of this list. Okay? You don't have to worry about address of the second element. It's done because you said this is the memory layout for the sequence of longs. So it will say, OK, the second element is 8th byte. You get var handle. And var handle it's like API of setting values, for setting values in memory. So you can set things and, of course, get. And you say, OK, set on this memory segment for this var handle. So var handle is to the second element of the array. Set this value and get this value. Let's run it. So what is interesting is because it's var handle, from var handle you can get method handle. Have you ever worked with method handles? Do you use Lambda? You work with method handles, okay? Underneath, it's all the way method handles. Do you use reflection? Recently, reflection was rewritten to method handles. So it's like low-level API to work with methods. It's similar to var handle, where var handle is handle to variable, and method handle is a handle to a method. So you can convert and say, hey, I want a method that allows me to set or get things. So give me a method handle. It will be not actually any method. It's just a handle. So that doesn't have to be a method underneath the method handle. It's basically give me a way to get values from this var handle or to set things. And then in return, you get a method that has the signature. So basically, signature of get is the memory segment as argument, long as return type, and when you want to set things is give me memory segment, you give memory segment and you get the offset, I mean the value you want to set. So if you say here that, for example, I don't want to have Java long, but I want integers, oh, how unprofessional. So then the handle will change if it will compile and run. See? Because we changed type, the type of the change of the handle also changed. Okay? Fun? I think it's fun. More sophisticated example is struct. Let's imagine that you want to work with C library, and C library returns some struct, some record, or accepts some record. So what you can do with foreign API is you can create a struct layout. So basically this baby. And you say, OK, I have a struct, and then I have a field that it's long, and this field is year. And there is a second field that it's short, and it's month. And then you have a third field, which is day, and so on and so on. So you can, this is a way to describe structs from the native languages and say, OK, Java, please, can you handle this? What's really lovely, you can then get var handles to every of this field. OK? So and you don't have to remember the layout, because as you say, please give me a handle to a field year in the struct. Okay? And then you can do all the lovely magic, setting variables and getting values. You can also get things like, here we have time zone, and time zone has offset. So we have a struct within a struct. As you can see, we can create struct within a struct. And I can say, OK, so give me a handle to this thing, okay, which is struct within a struct. How you do it? You say, OK, I have a time zone, and within this time zone, I have offset. Give me var handle to this one. So this way you can work with C structures, structs, and sequences and unions with this new API. Because it's method handle, you can do all the method handle magic. So basically, you can do this. Do you see this bind to? What it does, it says, OK, I get a method which signature is memory segment value in something, and I return long, OK? And then I can say, substitute the first argument with this object. So when I call, I don't need to pass memory segment, because it will be bind already. So type of this method will be here just time zone type. Okay. Let's see what will happen. Do you see it? You had, in all these cases, you had memory segment, you pass memory segment and you get short, okay? Because I did bind, so I say substitute, inject this parameter into method invocation and give him new method with different signature, you will just need to call short. What it gives you? You can return method handle and say to your client of your library and say you are allowed only to write in this memory region. Because you pre-bind the first argument, so they will be not able to access anything outside of this. Only this specific var handle, okay, if you do bind. What's even more interesting and sexy, because we have method handle, we can say, I want to have volatile access to this var handle. So you can have something that is off-heap, which you can have all the lovely Java memory model things like volatile, acquire, set, release, get, compare, exchange, making atomic variables on the off-heap things, all the things because somebody architected it 20 years ago in a way, okay, we will use method handle. So I can generate any type of access. Acquire, get and add all the atomic operations on this specific handle. Okay, it can be anything. 18 minutes. It's good. Are you with me still? This person is not here in the room, but I have a friend here, and he said once, we have time for something personal. He said once that I'm master of useless presentations. But they are quite good, thank you, Kuba, but they are absolutely useless. So this one is in top 3 of useless presentations. So, but I would try to prove it that it has some value at the end. Okay, so I showed you. I don't like slides. Slides are for me to remember that I showed you everything. So now with the foreign memory, you can write, read, and do all the stuff. It allows you also to do like padding and alignment. I will show you later. One interesting thing is unsafe. So as long as you create memory segments calling allocate native, everything is safe. Because JVM created things, JVM know where is this address, you probably created memory layout, so you know what's in the memory. But sometimes in C, as a response to your method call, what do you get? A pointer. And this pointer can point anywhere. What's even worse, the C code can delocate this memory, and we will still have this pointer in Java. Welcome back, core dumps. Okay? So what they did, they say, okay, we trust you. We know you are like adult people, 20 years in business, doing serious stuff. If you know what you are doing, we will allow you to read and access this memory that was not allocated by JVM. And it's called unsafe access. Okay? So if you get a pointer from C library, you need to do a little magic. I jumped too far. Sorry. This was bad. Yeah. So if you trust yourself, don't do it. Don't ever trust yourself. You don't trust your kids. Why you trust yourself? Is you need to say, I know what I'm doing, and I allow this module, the Java 9 module. So this is magical switch to the JVM when you started. They're like, okay, I allow native access from this specific module. Otherwise, the program won't start. So this is kind of like limited safety trust, but you need to make like a conscious decision that you want to have this access to unsafe pointers. Okay. Cool. Because we can write and read from memory, the next step is to call C libraries. So in the past, we had JNI, old, slow, hard to maintain, disaster. So we had a lot of different wrappers around it, Java Native Access, Java Native Runtime, JNI Easy, Java CPP. Basically, lots of things to make working with native code in Java simpler, but yeah, still JNI based. The problem also is a lot of Java code, mostly the SDK code, like files, sockets, need to call native code. They need to call system library. to open file, to open socket. So inside of JDK, we are using JNI as well. So what they say, okay, we'll give you a safe way to call C code, and you don't have to be C programmer to call C code anymore. Okay, because with JNI, you had to have some basic C skills. Again, at the moment, they only support C. They only support ARM and Intel, but I think things will get better. How it works? Basically, you have a class called linker, and it allows you to do two things. One thing is something called downcalls. So a situation when you have a Java code, and you want to call C code. Okay, you have Java and you want to call C. The other thing is called upcalls. When things get nasty, is when you want to call Java code from C. Why? For simple example, let's say you have a Java C library that takes as a parameter some closure, lambda, pointer to a function, some callback. And you want to be this callback to be a Java code. So you call C program, pass Java method as a parameter, and then you get like callback from the C code back. So this is upcalls. Examples. I need to change projects. Go this. So this is the simplest possible example I could think of to show how to call now Java, C code from Java. So basically you say, okay, give me a linker. There's like default native linker. And then you go to linker and say, give me a lookup. Lookup is something that knows how to find C code in your libraries. Yeah. The default lookup means, system, glibc, for example, on Linux, and all preloaded libraries, preloaded by default by the operating system. And then you can say, give me this method, C method. So you say, find symbol, it's here, and find method called getPid. GetPid gives you a PID of your process. And if you don't find it, just, it's optional, so we do. And then you say, okay, I have this symbol. The symbol is actually addressed to a method in native code. And I say, this is the signature. So this method only returns Java int. So what's interesting, linker will do automatic type conversion. So it will convert the C int to Java int. In the previous versions, it was much more complicated. Then you say, okay, this is a getPid method that will return Java int. And then you can say, again, it's method handle. Lovely. And you say, give me a handle to this method with this signature. And that's all, okay? When I do it, it will call C code. No, it won't. No. Thank you, IntelliJ, for all your hard work. You have to trust me. I don't know why it doesn't work. So basically, well, maybe I can force it. No, I won't try. Trust me, it works. So it's really, really simple. You don't have to write any example of any snippet of C code. And I was thinking about some crazy example how to do the opposite thing, calling Java from C. Okay? And if you don't know operating system, that's fine. I'll try to explain it. So basically, in Linux, there is something called signal. So you can send signals to your processes. Kill -9, the most famous one. Yeah. So basically, you send a signal to process to kill itself. And what you can do in Linux, you can register a handle to a signal. So whenever you send a signal to a process, you can execute some code. Okay. So what I'm doing now, I will try to install a signal handler that will call Java code when you receive the signal. Crazy? A little bit. So two things need to happen. One thing is I need to get a handle to my method, Java method. So I use method handles, and I say, OK, find me static method, and this is the method I will try to call, this one at the bottom. OK? Static method, and this is what I will call from C. So that's this thing. And what I need to do is get the upcall stub. OK? So why not direct pointer to this method, to Java method? Why some stub? Because this method can be anywhere. The GC can move it. The method can be compiled with JIT. It can be interpreted. It can be intrinsic. It can be native code. It can be anything in Java. So Java cannot give address on the heap. So what Java does, it allocates every problem in IT you solve by the enough number of indirections. So basically, you create an address outside of heap, and this address will have address to the Java method. And then when things like JIT and GC happen, this thing will be updated. OK? So we have a stub, which is pointer to a pointer. And then we say, OK, give me signal method to make it. Yeah, you have signal method in Linux, and it accepts a method with this signature. So you say, OK, I want to handle this signal, and this is my function to handle this signal. Okay, so I do exactly here. I say, OK, find me signal, and the signature of this signal is I return void, nothing, and I take a signal number and address, and this address is basically the stub. Okay. It will not work. Computers hate me today. Not only today. OK, I need to show it to you. Good old command line. You can almost always trust it. What's the name of this class? It's this one. Why am I doing this to myself? Doing showing code. Okay. Compiling sometimes helps. OK. So what happens now is I run this code. I can do it right now like this. OK. And I'm waiting for a signal. OK? And I will send signal 15 to this process. Do you see? It called Java code, and I called it from the outside using signal. One more time. Works and doesn't crash. So your C code calls Java code right now. OK? 5 minutes. OK. How do you feel about it?
Why are we doing it to ourselves?
For fun. Because have you read this article, Bullshit Jobs? It's a really sad article because it says majority of things we do, nobody cares about. So we should focus on the fun things. And here comes the fun part. Why I became programmer? Because I sucked at computer games. My brother was way better than me. So in revenge, I'm older brother. That's my right to take revenge on my younger. I wrote a game long time ago on Atari 800. And that's what gets me into the programming. He still killed me in this game, but who cares? So when I started to play with it, my first idea was, OK, looks interesting. Why I can change project. after, I would say, many years of writing, pushing JSON to databases and back, because this is what we do. Finding even more interesting ways to send JSON to database. And I said, okay, I will write a game using this, because I can call C code. So I will delegate all the hard stuff, rendering, playing music and blah, 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 to C. And then I will use DDD to design my game. I will have my Java objects. I will have everything that I'm used to. And I will not worry about hardware, because I will delegate the hardware stuff to C code. So there is this library in Linux called libsdl, simple dialog layer, that is used even in commercial games to write some as a foundation for engines. Think about it as a DirectX for Linux, okay? And I say, okay, so I will use this library and will import it into Java. And here is like crazy example. In this library is something called surface that represents like area on the screen. And this is the Java C struct that describes this. So I had to map this from the header file into Java. And as you can see, I can say even like I can do padding is the second line. Yeah, when you have, okay, I have 4 bytes, and then I have 32 bytes of padding, and then I have pointer to something called format, and so on, so on. So I had to describe all of this, okay, from the C file. And then I had to do some linking to methods. For example, SDL init. So this is the first method when you start the SDL. You need to initialize it. So I have I call it somewhere. Then we have all the lovely things like update the window, so refresh the frame, and I need to import it using the native linker into Java space and match the signatures. Okay? Does it work? Please. I will be nice to you. I will never ever say that's your last month with me. Oh. No. Okay. Not this way. The only thing you can trust in your life is console. One more time. Go away. Okay, thank you. Okay, and what we need here is this one. Sorry, gents, but we can blame IntelliJ. It's in Java. I'm just calling Java code. I mean C code from this. Okay? What's funny, if you don't trust me that this is Java, this is my lovely low-quality game loop. I'm handling events from the SDL in an engine, and I have my root aggregate objects, value objects, whatever you call it, called Minotaur. And then on the Minotaur, I have all the logic, like walking forward, attacking, moving. So the logic is in Java, the execution is in C. Excuse me? What can go wrong? Okay, let's do a closing because we're running out of time. of course, as you can see, so I had to generate all this header file, convert these header files into Java code. There is a work on a cool tool called JExtract. This is available in early Panama access builds, where you give a header file, and you say, generate me Java code from this header file. So you can call JExtract, give a header file, and then it will generate all this bloat code for you. It's not... It's targeted to the next, maybe probably 2 years later, Java version, but it works right now. I use it a couple of times. What's in it for you? Because I said this is user's presentation. Yeah. I think there is something. First, if you ever will work with huge, gigantic data sets that needs to fit in memory, GC will come and kill you. So you want to have things outside of the JVM heap, so you can use this. If you want to interact with other processes, non-JVM processes, JVM processes, you can use memory map files now with this API to communicate between two processes on the same machine. You can call C code at the moment. If you use drivers, all the drivers, machine learning algorithms, big data will become better, safer, and faster because the people who implement the drivers are using these low-level things, using unsafe, okay? And it will be much, much better and faster for Java to adapt for changes to hardware and OS operating systems. Like there's a little craze in the people in performance world about I/O uring from Linux, and now you had to wait for Java to implement I/O uring. Somebody in Oracle OpenJDK had to implement it for you. Now you can use this library for speed I/O operations using this API. Thank you. I was thinking about one thing, is will it help kill Python? Because Python is used because it's so easy to call native code, yeah? So maybe if you can call all this, high-performance ML libraries from Java, maybe it will kill Python, or maybe the next Cyberpunk will be written on JVM. Thank you. Thank you very much. Whew. Questions? Oh, yeah, okay. No. If var handles are like pointers, no, they don't. They don't suffer. That's what I said. They kind of like pointers. Okay. Regarding speed versus stability, how many testing has to get both? Oh man, what are the? It's too fast. Speed's okay. Rust. Yeah, we are considering having some things in Rust as well. So you can Rust. At the moment, I don't think you can run directly Rust because we support C. Basically, we support all the C native calling libraries. So, but yeah, it will probably happen. Databases, yeah, the databases kill big data processing. And game engines. That's what I think. The next one. What are two other useless presentations? In a month in Krakow, I will give a presentation like 1.5 hours about method handles and var handles, and this is the top of of the useless presentations. Yes. So basically, at the moment, you cannot, but the way it's designed, it will be possible to access other memory spaces, like, for example, NVRAM and FPGA probably at some point. So the first version will support confiner. I don't know. I haven't tested with Vloom, but I suspect it will be treated like if you create something in a virtual thread, you can only access this from this virtual thread. But I haven't tried it. C Java type conversion assigned. Still thinking, okay? It's work in progress. Yes, because allocated memory on heap will need to be handled by GC, okay? So there is a cost, like there are two costs of memory allocation, direct and indirect. The direct cost of memory allocation is time spent on calling malloc. And then indirect cost of allocation is freeing this memory. And in GC, you have higher indirect cost of freeing memory. Yeah? What do you think about using JExtract? It's super cool. And it doesn't support unsigned. Thank you very much.